those things, if you squint at it, you might say, yeah, okay, maybe they're kind of like the same, but there's an important nuanced difference here. And by the way, if somebody wants to object to my particular usage of the words, there's actually lots of different meanings for these words, and it's hard to nail down one particular thing. So I'm trying to be as consistent within my own usage of these things. But there's actually, if you go and read Wikipedia pages or other texts on it, you'll find a whole range of different opinions on these things. But my way of explaining to you what concurrency is, rather than saying with parallelism, two things are happening at the exact same instant, I would describe concurrency as two higher level tasks happening within the same time frame. So rather than an instant, we're going to look at a time frame, and we're going to say within this time frame, two higher level operations are going to occur. To understand the notion of higher level items or higher level operations occurring, we also have to understand that higher level, or what I might call like macro level tasks, can be broken up or thought of as being broken up into micro level tasks. So here's a way to visualize the macro level and the micro level and how these things might go together. So on the left-hand side, we have this yellow-orange task, or the macro level task, which is broken up into those individual numbers, 1, 2, 3, 4, which would be micro level tasks. These are my made-up terms. These aren't official terms, but macro level and micro level tasks. Okay? And then on the right-hand side, we have another macro level task represented by that blue-green color, and it's broken up into 3 pieces, 1, 2, 3. Now, for the easiness of math, I'm going to pretend and assume that each one of these micro-level tasks takes 1 full second to complete. So this overall system, to do all of the tasks, it's going to take 7 seconds. Does everybody agree with that? Because it's a single-threaded system. Nothing can happen at exactly the same moment. So those 1-second micro-level tasks are going to have to be scheduled in some way that all 7 of them finish, and that's going to take 7 seconds. Let's pretend that the yellow-orange represents an AJAX request and response cycle. Fire off a request, we get a response back. And let's pretend that the blue represents a scroll, that we scrolled on the page and it repainted everything because we scrolled to a new location on the page. These two operations have to fundamentally happen on the same thread. The entire user interface of our browser is happening on the same thread. So our JavaScript, the garbage collector, the style engine, the repaint, everything, it's all happening on one thread, which means we kind of have to worry about contention. And if you've ever had an animation on your page have jitter in it, you know why that happened? Because something contended on the UI thread. At that moment, your CSS engine was trying to, or your layout engine was trying to repaint the page. It's 60 frames a second way that it's repainting your page. It tried to do that, but at that exact moment, something else was running. So it had to wait an extra moment, and that's what created that jitter. Single-threaded. So if we have these higher-level, macro-level tasks that we want to happen concurrently, I want the yellow and the blue to happen at the same time. Why? Well, let's imagine they don't. One way of scheduling this system, one way of scheduling this program, is to do all of the yellow first and then all of the blue. What would that look like on our page? Ignoring the 1 second thing for a moment, what it would look like on our page is that it would look like I clicked the button to make an AJAX request, and while that was happening, I tried to scroll my page, but everything was completely frozen while that happened. And then after it finished, then it sort of, jumped back and caught up. We actually have precedent for that. It's called synchronous XHR, synchronous AJAX. One of the worst evils perpetrated upon the web platforms. Terrible idea. There are people out there that are crying and literally complaining on standards lists saying, how dare you take away my synchronous XHR? It's been deprecated and removed from the web platform because it's a really bad idea. It's a terrible idea to schedule it that way, isn't it? Because even though the overall system would still take 7 seconds, that particular choice of scheduling those micro-level tasks would feel terribly inefficient. Does everybody agree with that? Just from a user experience perspective. If, on the other hand, we chose to interleave these things together, where one thing might be blocking so we can do something else while one thing is blocking before it can move on to the next thing, if we chose to schedule those things in an interleaved fashion, the overall system might still, in fact, take 7 seconds. But the perception of the performance is that things are going to be happening in parallel. Really, more importantly, we should be saying those things are happening concurrently. The AJAX and request and response is happening concurrently with the repainting, even though at any given instant, only one of those micro-level tasks is occurring. So, just to visualize that, my fancy animation took me about 2 hours to get right in Keynote. here's a way of scheduling those micro-level tasks onto that single thread in the middle called the event loop. I don't know why that advanced. The single thread in the middle called the event loop. That's what we call it in JavaScript. At any given instant, it's only doing one of those things. So when you have an AJAX request that comes back and you need to fire the callback for a response, if at that moment somebody's already executing, nobody gets to cut in line. Right? It's not like your response callback gets to interrupt and say, oh, it's time for me to run. You know what it does? It gets at the end of the line, just like everybody else. So when the garbage collector says, I need to collect some garbage, and the style CSS repainter says, I need to repaint the page, and the layout engine says, I need to do some work, and the JavaScript engine says, I need to fire this response callback, and every single one of them, it's a first come, first serve, everybody gets at the end of the line. That is fundamentally what the event loop is. Okay? So that's just a high-level view to help you sort out what's going on. And the main point here is that the scheduling of this is not always entirely within our control. Sometimes it's race conditions that choose one versus the other happening. Not all of that's happening. But there's an awful lot of coordination necessary. Sometimes it's the coordination of when things happen, but oftentimes it's the coordination of responses to things happening. Because it's not always a very serial, like do this, and then when that's finished, do this, and then when that's finished, do that. Oftentimes it's much more complex, like, hey, go do these 3 things in parallel, and then when at least 2 of them have finished, you can move on and do this other thing, and then when that 3rd one comes along, you can branch out here and do this other thing. And before long, it's just crazy complex tree of different states of things that could happen. And it's that complexity that we have to manage in our programs. It's that complexity that begs for us to have better patterns for concurrency management. That's what asynchronous programming is, managing our concurrency. Okay? So that's a motivation for you from a philosophical and conceptual basis, a motivation for why we go to the lengths that we do to try to write the programs that we do. Everything that I'm going to show you in this workshop is something that could fundamentally be done with nothing but the callback. There's no new functionality here. But we're going to see that the callbacks fundamentally are insufficient for expressing the higher and higher orders of complexity that our modern JavaScript programs are doing. Our modern JavaScript programs are falling all over themselves because we need these higher order patterns, and we're not disciplined enough to learn them and implement them. We just keep doing the same thing we've always done because it always worked, and it always worked, and it always worked. This is a call to arms to say the new baseline of competency as a JavaScript developer is to have a much more sophisticated, strategic, and tactical approach to your concurrency management, to your asynchronous programming.